there is an embedded function in green here inside the square root function, and then there's a product here as well. Okay, so we have to apply the chain rule and the product rule. So I'm just going to do it like this at first. First of all, I'm going to show that here I'm going to differentiate the outside here, and I'm going to have to apply chain rule when I differentiate this outside function. Okay, and then I'm also going to apply product rule at the same time. So here's my product rule. So I'm going to write it like this. Okay, so you can see that what I've done is I'm going to apply, if you kind of notice on the outside here, this is basically the product rule formula. The derivative of the first term times the second plus the first term times the derivative of the second. Now within the product rule, this is the only point here that I'm going to need to apply chain rule, because this is only when I differentiate this red part I'm going to need to apply chain rule. Okay, so I'm just going to give myself a little bit more space here. So when I differentiate this, it's going to look like this. So first of all, I'm going to differentiate the outside. So I'm going to end up with 1/2 x to the negative 1/2. Okay, and that's going to be my 3x squared plus 4. But since I differentiated an outside function, now I have to apply the chain. So I have to add on as a chain the derivative of the inside, which is times 6x. So there's where I apply the chain rule. Nowhere else do I need to apply the chain rule, because the only other derivative I have in this expression is this derivative here, which I'm going to differentiate. I don't need to use chain rule here. Okay, so then I'm going to just fill in the rest here. This is going to be cos x. Okay, the derivative of cos is going to be negative sine x here. And here, the original function, I don't change anything here, so I'm going to end up with 3x squared plus 4 to the power 1/2. So there it is. So within the product rule, where I differentiated an embedded function, I applied chain, but that's it. So now I'm done. There's my derivative. I'm not quite done, but I've done the derivative. Okay, I should probably simplify this. So I'm going to end up with, looks like 6x cos x here. Okay, and then all over 2 square root 3x squared plus 4 plus, so it's going to be minus sine x times the square root of 3x squared plus 4. So some people would leave it like this. Some people might put it in the common denominator, and that would actually give me, get rid of the square root in the numerator. I'm just going to leave it like this. But you can see how the main idea is this embedding of the chain rule inside the product rule. So this is essentially the same thing. I'm going to have an outside function here. This is my e function. And then inside the e, I've got an embedded square root function. Okay, and then I also have my product function here. So what does this look like? Okay, so I'm going to, when I differentiate this, I'm going to take the derivative of the first term times the second term plus the first term undifferentiated, okay, times the derivative of the second term. So it's going to look like that. Okay, and essentially, again, I have the product rule going on here. So as I apply the product rule here, when I differentiate the first red bracket, that's the only time I have an embedded function. That's the only place I'm going to apply chain rule. So here I'm going to differentiate e, and then I'm going to differentiate the inside. So there's the derivative of the outside times the derivative of the inside function, which ends up being 1 over 2 root x. Okay, so that's the only place I'm going to apply the chain rule. Now I'm applying the product rule on this. So I end up with e to the root x, and then the derivative of sine is cosine. So there it is. There's my derivative. So I just should clean this up. I'm going to factor out my common factor of e to the root x, e to the square root x. Okay, this is going to be sine x over 2 root x plus cosine x. Okay, so there's a simplified version of that same derivative. So here I have a product, a quotient, and inside the denominator I've got chain rule. Okay, so this is going to be a little bit more difficult to do, but let's try to identify all the parts here. Okay, so I'm going to identify all the different parts here. So I've got my 3x function. Okay, I've got my cos x function. Okay, I've got my outside function square root, and I've got my inside function here. What color will I choose here? Let's choose purple. I've got my inside function, the 3x squared plus 4. Okay, so anytime I differentiate the denominator, I'm going to need to apply chain rule. But other than that, I've got all these other parts here that I've got to consider. Okay, so I'm going to first of all do this. I've got the derivative of the first term. Okay, so I'm going to differentiate the numerator, and the derivative of the numerator is going to be product rule. So it's going to be the derivative of the first times the second plus the derivative of the, so it's the first undifferentiated times the derivative of the second. Okay, so there's my product rule. Okay, so that's going to be the derivative of the numerator times the denominator undifferentiated. Okay, it's going to look pretty big. Minus, I'm going to contain all that in brackets here. So that's going to be just the numerator undifferentiated. It's going to be 3x and cos x. Okay, so the numerator undifferentiated times the derivative of the denominator. Okay, so this, I'm going to have a little bit bigger here because this is going to then, this is where the chain rule is going to be applied. Because see how we have the derivative of the denominator there? It's going to apply chain rule. Okay, so I'm just going to finish up this first. Okay, so then this is all over the denominator squared. Okay, so I'm just going to start with the hardest part here, which is the denominator. Okay, in here, this is kind of easy because I have 3x squared plus 4. Square root squared is going to undo each other. In this part here, I'm going to differentiate the outside. Okay, so there's the derivative of the outside. That's my outside function. But I have this embedded inside function. Because I'm differentiating the outside, I have to apply the chain rule to accommodate that inside function. So this is the only place where we're going to apply chain rule. Okay, so there it is. That's the hardest part of this expression. The rest of it really is just differentiating the rest. So I differentiate the numerator. When I differentiate the numerator, I have to apply the product rule. So it's going to be 3 times cos x plus 3x times the derivative of cos is negative sine. So negative sine x. Okay, and then the denominator, although it's messy, nothing actually changed in the denominator. They're just bringing that denominator to the top. I don't differentiate the denominator in the first part, differentiate it here. Okay, and then the second part of that numerator is just going to be 3 to the x times cos x, because nothing changes. Okay, and then the derivative of the denominator, which that's where we apply the chain rule. Okay, so there it is. There's my derivative. Okay, now I don't know if I really want to simplify this, but I think we'll give it a shot. Okay, so first of all, I'm just going to get rid of that square root by multiplying the top and bottom by 3x squared plus 4 over square root 3x squared plus 4. Okay, so that's going to make that into whole. So what do we have here? We're going to end up with 3 cos x plus 3x sine x. Okay, that's going to multiply by 3x squared plus 4 because the square root gets rid of the square root there. Okay, minus, I'm going to simplify this to 3 and 1. So I get 3x times 3x is 9x squared cos x, and then the denominator is gone. Okay, so I think I've taken care of that. That's the numerator there. I don't think I have any, like, oh, I do have some like terms, so I'm going to have to do one more step in simplifying there. I multiply through in here, it's going to be 3x squared plus 4 to the squared times half. Sorry, this is square root squared times power 1/2. It's going to be power 3 over 2. Okay, so when I can see that I actually can cancel out this 9x cos squared here, because I'm going to generate a 9x squared cos x here, so let's do that. So I get 9x squared cos x first plus 9x cubed sine x plus 12 cos x plus 12x sine x minus 9x squared cos x. Ooh, that's a lot of writing. Over 3x squared plus 4, 3 over 2. We can cancel those out. And so, you know, there's some common factors involved there, but actually we might as well factor it out. Common factor, actually that's not, because it's not there's no common x factor there, so it's not going to help us solve anything. So 9x cubed sine x plus 12 cos x plus 12x sine x, and that's all over 3x squared plus 4 to the power 3 over 2. Okay, so there's a lot going on there. Hopefully I didn't make any mistakes, but there is my derivative simplified. Now that said, this, if we want the derivative, there it is. Okay, we can actually use this derivative to calculate slopes if we wanted to. So for the most part, you can stop there unless you need to simplify for any particular reason.